several conferences in the area of material physics and nanoscale science. So please welcome Professor Mohan L. Verma, sir.
So, hello everyone, good afternoon, and I think after lunch, well, I have stored sufficient amount of energy to eat, and the motto of my teaching learning process is we have to enjoy learning. So, to enjoy learning, you have to respond properly on time. If you are facing any problem during this hands-on session, you have to respond either in the WhatsApp group or in the chat box of this Zoom meeting. Mr. Narendra is with me. Yes, Narendra, please. Mr. Narendra. Narendra not.
Yes, sir. I'm here, sir.
So you have to share your screen, and today's session we have to I think complete some Linux command, basic Linux commands for beginners.
Excuse me, sir. Your voice is not clear.
Participants, can you hear me clearly?
So there is echo of voice.
Okay, so now my voice is okay. Narendra?
It's better than.
I think there will be some problem in your mic is okay. I think your voice is clear. Hear you. Others participate?
No, sir. Again, the problem. There is echo of your mic.
क्या करना brightness? हाँ ये
Hello.
Okay. It is better now, sir.
It's far better, sir, now.
Hello everyone, good afternoon. Now ready? We are introducing some commands and the Siesta have So Narendra is here. And we should start because it's already.
Yes, sir. Yes, let me share the screen.
So we have offline participants here in the Science College lab as well as in this seminar hall and also in the SSTC campus in my lab. So we have to take care of all these participants along with online participants. So you have to move slowly.
Yes, sir. Yes.
Okay, so this
So thank you, sir. I shared one link in the WhatsApp group that is related to day one hands-on tutorials. I requested all the participants please download that day one zip file. You can download that folder. Participant, did you get that folder? It is day one. Name is day one. Here in this folder, you can see 3 to 4 tutorial. As most of the participants are non-Linux users, so first we will do some basic Linux command, how Linux will work. If you open this day one tutorial, T1 tutorial, that is all about Linux, basic of Linux. This tutorial is prepared by Dr. B.K. Sproul. If you go to this tutorial, it is very clear and easy to understand for a beginner what Linux is and the distribution of Linux. Like in Windows, we have Windows 10, 11, 7, XP. In Linux, we have few distributions like Ubuntu, Red Hat, Linux Mint, Debian, Fedora. And another important thing in Linux is terminal or Linux shell. So what it is a command line interface where if you want to do any operation, you have to give the command and the command will do this thing for you. Where you have to give the command, you have to give the command in the terminal. So first thing is how you can open the terminal. If you go to your Linux machine, how many of you enter to your Linux machine? Sir, you are not audible.
Open command window. Open command window. And you have that tutorial.
Any participant have any issue with your Linux machine that you installed yesterday? Itika Jain.
Please screen करो ना. Yes, I opened the machine.
Mrityunjay, you are saying unable to open this link. Which link? Mrityunjay, can you unmute and then okay, WhatsApp link. Okay. Let me reshare it to you. Try now. I pasted it in the chat. Okay, when you open your machine, then how you open your terminal? You have to be press Control Shift T. Sometimes it work with Control T, not T. Like this one, Control Shift T, or sometimes it works with Control T. I have this white background terminal, but you can get something like this. When you press Control Shift T or Control Alt T, a terminal will open in front of you. Or what you can do, you can go to all the application, then you search for terminal. Click on it, and a terminal will appear in front of you. The first command is ls, that means list. If you hit ls means list. Your first command is ls. Ls means list. If you want to see the list of ls means list. If you want to see the list of your directory, directory means folder here. In Linux, we usually call directory a folder as a directory. Directory means folder. Okay, then the next command is ls. Suppose in your directory you have many files and you want to see a particular type of file. Like in this case, we have PDF1, PDF2, PDF3. I don't know the first starting letter of these files. What I want to know, that what I know only that the PDF file that I want to see in my screen. So what I will be do, I will write ls star dot the last letter, that is the PDF. Then hit the enter. Now you can see only the PDF file is appear here. You can do opposite, like you don't want to you just want to know all the files, that is suppose ls, you want to see the file that start with t letter, like t1, t2, t3. So what I will be do, I will be do t, then star star. See, now I have all the files that started with t is appear here. As you can see here, there are few another file like atom, silicon.ftf, silicon.psf. It is also showing here. It is because of in our directory we have t1 folder, and inside that t1 folder we have some file. So when we press this ls t dot star, it will give you all the information, all the files inside your directory. It will appear on your screen. The next command is cd. Cd means change directory, like change folder. So suppose before going to cd, I want to show you one command that is pwd, that means present working directory. If I hit pwd, you can see a path is showing here, that is home, Kumar, iOS, and day one. I'm here. I am inside this folder right now, day one. Now suppose I want to change path. I want to let me first press ls. I want to go this t1 directory. What I will be do, I will be do cd. Cd means change directory. Then my next folder name, that is t1. Like this, what I did, I have one folder here. Okay, this is not working. So what I did, I was here in this day one folder. I press CD and T1. What it will be, it did. I just go from this day one to T1 folder. I change the folder, this directory. If I press PWD, you can see now the path is home Kumar day one T1. Before that it was home Kumar, then the day one. By pressing this command cd, you can change the directory. Now I want to go back to this day one folder here. I want to go back to this folder. So what I will be do cd dot slash means if you want to go back to the previous directory, then hit enter. If you write pwd again, you can see the path is again cd Kumar, then the day one. Then the next command is gedit. 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 Gedit is like your notepad editor or text editor. If you hit gedit and enter, a kind of word file you can see in front of you. You can write anything here and save this file. Okay, suppose I want to see this silicon.scif file or this readme file. What I will be do gedit for silicon. I will write silicon.cif, then hit enter. This file is, you can see, you can edit, you can do, you can find, replace. It is kind of your word file or notepad file. Okay, your next command is cp. Cp means copy the file. If you want copy file from one directory to another directory, sometime we don't want to use, you can go directly like this and copy and paste, but sometimes we don't want to move our hand from keyboard to mouse. In that case, you can do this with your terminal using cp. Cp means copy. CP is copy. Suppose you want to copy a file. Participant, I am audible.
Yes, sir.
Anuradha is saying that Anuradha not able to hear anything. Anuradha, check with your internet. Your next command is CP. If you want the copy file, suppose I am trying to. So what I want to do here, suppose I have this folder, let's say the folder, let's say folder 1, I'm here, and I want to copy a file that is just another folder, let's say folder T2. I'm here, what I have to do, I will press CP, then space, dot slash, and the file name, let's say silicon dot CIF file. So how we can do this? We can CP dot slash. If we press tab 2 times, you can see all the content of day1 directory. I am here in this T1 directory, but I press CP dot slash, then 2 times tab. You can see all the files of day1 directory, not the T1, because I press dot slash. So now I want to copy this silicon.cif. So how you will be do CSI, then you hit again tab, then press dot. Dot means the destination is the same. Now if you hit ls, now you can see the silicon.saf file inside your T1 folder. Let me remove it and I will be do it again. Okay, I'm here in this T1. Now I want to copy a file silicon.cif that is in day1 folder. So what I will be do cp dot slash, then silicon.cif, then I hit the dot and enter. Now if I press ls, you can see before that we have only 2 files and 1 folder here, but now we have one CIF file. We directly copied it from the day1 directory. Now I want to remove this file here because I don't want this file here. So what I will be do, rm means remove, then silicon.cif, enter, and again ls. You can see now the file is disappear from here. Before that it was here. Okay, next file is you if you want to create the folder, that means directory. So you can do mkdir. Mkdir means make directory. mkdir, then the directory name, let's say Kumar. You can hit enter. If you hit ls, you can see the Kumar directory is created here. Or if you go directly here, you can see inside T1 the Kumar directory is created here. Okay, now if you want to create multiple directories, so what you can do, mkdir, let's say test1, test2, test1, test2, test3. You can create multiple as well. Enter. If you press ls, you can see the test1, test2, and test3 files is here.
Narendra, can you hear me?
Yes, sir.
It's a little bit slow. Visuals. So give some more minutes.
Okay, sir. Okay, I will repeat it again.
Yeah.
So what I did, first command, suppose I have this directory, day one. In this directory, I have many files like 1, 2, 3, 4, and so on. What I did in my terminal, I press ls command. It will show you all the files of that directory. Then the second command is cd. Suppose I have this directory 1, 2, and 3, and this directory 3, 1. Directory means folder 1, 2, 3. So I am here right now in this directory. I want to go in this inside the directory number 2. What I did, cd, I press the command cd to change the directory, and then the file name cd space 2. Now, if I want to come from this directory T2 to back to T1, what I did, cd space dot slash. Then the next command I said gedit, gedit. It is like your notepad. The next command is mkdir to create the files. If you want to create a folder 1, 2, 3, you press mkdir, then the folder name, let's say 1, 2, 3, and so on. Sir, can I move ahead?
Yeah, proceed.
Yes, sir. So next command is to remove or to delete the file. Suppose I created a folder here, test1, test2, test3. I want to delete this folder from here. So what I will be do, remove -dr, then the folder name test1, test2, and test3. Remove rm -dr, then your directory name. If you enter and type ls again, you see this file test1, test2, test3 is deleted from your directory. The CP command I already explained. Suppose you are working in this directory T1 and you want to copy a file that is any other directory, let's say T2, and the name of that file is uh, silicon.cif. So in my terminal, what I have to do, I have to write cp space, everything in small, then dot slash, that means I back from here, then I press tab. If I press the tab in my screen, all the content of this T2 directory is appear. Then you press si dot cif and then dot, and you hit enter to copy the file. I'm going to repeat it again. cp dot slash silicon.cif, or any other file. Let's say I want to copy this PDF file T1 Linux command.pdf. So what I will be do, cp dot slash T1 Linux command.pdf .dat. Now you can, if I press ls, you can see a file Linux command.pdf is here. Don't forget this dot here. Okay, next command is vi, that is kind of a terminal editor. One command I showed you before is gedit, that is notepad editor, kind of notepad editor. Now the vi is your terminal editor. Suppose vi and silicon.fdf. If I hit enter, a kind of the file, that silicon file is appear on your screen. It's so long file, but it is in inside your terminal. To exit from the vi terminal or vi command, you have to press escape, then colon and q. Again, I'm doing it. vi silicon.fdf. And let's say I did some changes. If you want to do some changes in the vi command, using vi command, you have to press insert first, then you can do any changing. Like I want to delete this line from here. Now you want to save the file, you have to press escape, colon. Now you want to save and exit. For save and exit, you have to do WQ and enter. But for now, I think gedit is good for the beginner. The next command is grep, G-R-E-P, grep. Grep is kind of to find a particular text in your file. I'm using grep space semicolons. Then you can enter the keyword that you want to find. Let's say silicon I want to find, and where let's say in this silicon.ftf file, inside this silicon.ftf. Enter. You can see the silicon that you enter SI inside these columns, grep space colon, then the word that you want to find inside this file, all the keyword is on your screen. Shakshi, please go to your that day one directory, Shakshi. Jyoti, please go to your that directory, day one directory that I shared with you. Shakshi and Jyoti.
Sir, which directory?
That I shared with you. I shared one link in the WhatsApp group. Or in the chat box. Download a folder day one. And then open the terminal inside that folder. What you have to do, this link I shared with you, you can directly go here and download it like this one. I download it, then go to your download and copy it and paste anywhere, or you can directly go there like this one, copy, then extract here this folder, because I already have this one, so it is, I'm going to delete one. Then go day one, then right click, open a terminal here. Sajal is doing good. Sajal Vishwas. Shakshi, did you get the day one tutorial, day one folder?
Yes, yes, yes.
The another command is sudo apt-get install. If you want to install anything, any software, you can directly do it using sudo apt-get install. Let me install G Fortran and I hit enter. Now it will ask for your password. For VirtualBox user, if it will ask for password, you can see a file readme for window users. You can go here. Here is your password for window users. I'm using Linux, so I'm entering my password. And the G Fortran is installed. How you will be install sudo space apt hyphen get space install and then the software name. The next command is, it is not a command. If you want to see the history, you can directly enter history. You can see the command that I gave, all the command is appear. If you just simply press history, history, history. So we learned two commands. One is cd, first one is ls, then cd, then pwd, that is present working directory, then cp, then we learned about vi, then grep and gedit. Now I am going to, you can see we learn about these few commands: ls, cd, pwd, cp, vi, grep, gedit and history. Okay, so these are the few basic commands that you should know. Now I am moving to the T2 tutorial, that is pre and post processing tools that we need during this workshop. You can go this tutorial and you can try other commands as well. But few basic like ls, cd, cp, grep, gedit, I explained you. Now, if you open this T2 pre and post processing tool that we need to generate our input file, that is FDF file for Siesta, and the post processing to visualize the structure or design the structure. So you can go T2 PDF, that is T2 post processing tools .pdf file. You can see it is we did this, so you don't need to care about these things. Now these software that we will use in further hands-on session. Some software are used for structural designing and some for the post processing, to see the structure of your system, to plot your data. The first one is Avogadro. What you have to do, you have to just copy how you will be install it. As I said, sudo apt-get install, then the software name. You can try, you can just simply copy it here and paste in your terminal and hit enter.
Narendra, 1 minute. So,
Yes, sir.
friends, I think some basic commands you learned, and as an assignment, you have to complete remaining commands given in tutorial 1. And the second part, that in the tutorial 2, you have to install that pre and post processing tools. In the molecular modeling, similar to that experimental work, we have 3 parts. One is for the material preparation, designing of material. So we have to use some tools to design materials, whatever materials we are going to study. So we have to design that material. So we need those tools. So the first part will be the installation of those tools. Second part, second with that Siesta, that will optimize the material. So second part will be the processing of that material. First is the preparation, realizing the material. So that optimization process, we have that system. And then after processing that materials, we need its characterization. Just like XRD, same team in experimental, we have to characterize the materials, means study some properties. So we must have some tools to observe those materials. So the visualization tools are there, plotting tools are there. So we have to install all these tools in this tutorial number 2. Okay, so Narendra, please continue.
Yes, sir. So first is to install few software that we need, like Avogadro. So what I did here, sudo means super user, apt get install, then the software name Avogadro. I hit enter. Now it is asking for, do you want to continue? And say yes, press Y and enter. It will take a few seconds. Done. Okay, now the next software is GDIS, sudo apt get install, then GDIS. Hit enter. It will be installed. The next software is GDIS. What you have to do? The same before, sudo everything in small, apt-get space install space GDIS. You can see also here in the tutorial. Biswas sir, you have to press Control and plus sign to increase the font. Control and plus plus. You can try Control plus plus plus, whatever you want. If you decrease the font size, Control minus. Sorry, Control Shift plus. Control Shift plus and Control minus to decrease. Control minus to decrease. To increase, Control Shift and then plus. To decrease, Control minus. Okay, so next software is that we need is Jmol. Jmol. Sudo apt-get jmol. Sorry, install Jmol. Press enter. I already installed this software. Maybe sometime it will ask for, do you want to continue? So press Y. So next software is Molden. Sudo apt-get install Molden, Molden. You have to press enter. Sometimes it works with the apt-get, and sometimes it works with apt without this get. Sudo apt install Molden. It is saying package error. Before that, it is also the package error. So you can try snap as well, snap. How? For Molden only, sudo snap snap install Molden. Because I already installed it, it's saying Molden is already installed. So most probably this command will work to install the Molden software, Molden. Okay, so next one is xcrisden. Sudo -get install XTRYSDEN. These are the few software that we need. For xkristen, sudo apt-get install xkristen. The last one is xmgrace. Before that, it was xkristen. Now it is sudo apt-get install. It works with the Grace, not xmgrace. The name of software is xmgrace, but you can install it with Grace, Grace, not xmgrace. It known as a xmgrace, but for installation, what you have to do, sudo apt-get install grace and enter. I'm entering history again. So we installed Avogadro, sudo apt-get install Avogadro, then gdis, sudo apt-get install gdis, then we install jmol, then we install molden. Molden will work with this command, third one, then xkristen, then the grace, that is xmgrace. Okay, so I'm going to next tutorial, that is part B of T2 tutorial. That is all about how this software will work. The first one is GDIS. GDIS software, we need this software to generate a FDF file, that is the input file for Siesta. We will use this software that we installed, GDIS. So it is a free software. We installed it with a simple command. Okay, now if we open a terminal, just right click and open a terminal. Open your terminal and hit enter GDIS and then enter. A black screen will appear in front of you. Anyone have any issue up to now? How many of you opened the GDIS? Sajal Biswas sir opened it. Anyone have any issue? I'm moving fast or slow, sir? Should I wait you or should I move? Participant, anyone have any issue?
Narendra,
Yes,
we
sir.
45 minutes. So,
Yes, sir.
I think that preparation of FDF file we should cover or all these tools you will in,
FDF file and then basis set calculation. I will be show you one calculation, then rest of the things they will follow.
okay, so remember this 45 minutes we have to complete. Okay.
Yes, sir. Okay, so how you will be create a FDF file or input file for Siesta? What you have to do when you hit GDI, when you open the GDIS, a black screen will open in front of you. So what you have to do, you have to go from here, model, then editing. You have to go model editing. Then here you can see you have add atom, add bonds, delete bonds, and normal mode. So what you have to do, you have to click on this add atom and then come to your black screen and click. Not working, what happened? You have to open GDIS. Oh, sorry, I need to open a model first. You have to hit this plus icon first, new model. New model, here you can see just below the edit, the plus icon. The first one is open new model, save active model, then the new model. You have to click on this new model, then go to editing, model editing. Just here you can see the model editing. It is here, you can see just below here in the corner, model editing. And then you have add atom, add bonds, here you can see, and delete bonds and normal mode. What you have to do, press on this add atom and click in your screen, that black screen. Okay, now you have to give the label of this atom. Suppose I want this atom as a silicon. What I did, I named the I gave the name, that is Si silicon, and hit the enter. Now click again a normal mode here. You can see here the normal mode, and you can see this atom. Now you can move it from here and there. Now if you go to file, then save, then it is saying new model. From here, you can save an input file for in the term of CIF. You can save it in the term of XYG. You can save it for Gaussian. You can save it for games. Demol and many other software are there. For Siesta, because we need the input file for Siesta, so you have to save your new model as a Siesta. You have to click Siesta here, then press on save. That's all, simple. Now it will create a FDF file with all possible parameters. If I minimize, you can see my new model.ftf file is created here. If I open it, this is our FDF file. That is the input file for Siesta. Okay, now suppose you want to create a carbon nanotube. So what you have to do?
Yeah, Narendra, 1 minute. So we have to give the information to computer and to give, because that computer is a dumb box. If information is proper, you are giving proper information regarding that material in terms of its elements uh, in uh, in that particular system. So for that, we have to create one input file, and in this system, whatever that tool we are going to learn, that in this system we have one FDF file, that is the input file format. So the detail will be discussed later, but this is FDF file, and it is especially for system. We have by using this GDIS, this is one material preparation tool, one can say. One can use this GDIS for different molecular modeling softwares, and that list have been shown by Narendra. So, but we have to work it for Siesta, so we can save this file in terms of CIF. CIF, this is related to crystal information. XYZ, it gives the coordinates of that particular elements, or especially that Siesta. So this will give in terms of that dot FDF. So now the detail will be discussed later. So okay, proceed, Naren.
Yes, as sir said, when we do the simulation, we don't have a single atom a single atom material, or kind of a simple material that I showed you here. So what sometimes we need a complex system, like the number of atom. When you have multiple number of atom, and it is difficult to design by adding atom by atom. So for that, we have database available on internet. What you have to do, you have to go internet and search for material project. Just Google it, material project, and then go to material project home. Then you need to sign in, because I already signed it here. So maybe let me redo it again. Material project, just enter. Okay. And then I think sometime it asks for to register. Just register with your Gmail or whatever. Then you click on start exploring material. Suppose I want the silicon. I can search by element, by name, or by formula. So I'm going with formula. Let's say silicon. Then I hit enter. You can see all the possible files, possible data of silicon is here, like silicon in cubic, hexagonal, then cubic with a different space group. Let's take any example. I'm going with this hexagonal. So what I will do, I will press this MP165 ID number. I press it here. Now you can see it will show you the structure. It's something like this. Then you have to export it as a CIF file. Then you can save it as a CIF file. Mostly the data available on internet either in CIF or in XYZ. So suppose I downloaded this unit cell in CIF format. So what I have to do, just open a terminal. I think I downloaded it here. This one. Let me paste it here. I have already it here. See what you have to do. Open a terminal. Just hit enter GDIS, and the file that I downloaded, ls gdis silicon.cif file. I downloaded it from internet, this silicon.fdf file. Now I'm going to open it in GDIS software. Just hit enter. You can see this is your system. Now if you go to here, display image, you can enlarge it either in X direction, Y direction, or G direction. Suppose in X, Y, and G, you can enlarge your supercell. Sorry, your unit cell. And then you can directly save this. Save. As I said, you have to do here Siesta. Give the name. I'm giving the same name and save. You can see this new model.ftf file of silicon. Okay, suppose if you want to create a nanotube that is in round in shape. Suppose you want to create carbon nanotube with 6x6 chirality. So what you have to do, you have to go this icon, model editing, just below then this view, this icon, model editing, this one. So here you can see the nanotube. Here the chirality, you can choose the chirality like 6. Then you can choose the number of your not number of atom, but the species like carbon, and the bond length between one carbon and the second carbon. If I press on this create nanotube, you can see, but I did one mistake. I didn't create a new model here. I'm going to repeat it again. I created a new model. Then I go here. Then I choose the chirality, that is 6 for carbon 1, and then the carbon 2, then the bond length, and create nanotube. You can see your nanotube is something like this. Now you can do boron and nitride as well. If you hit nitrogen here and boron here, and the bond length for now I'm saying it is 1.44, and the create a nanotube, you can see boron nitride nanotube. But this is not a boron nitride. I did again the same mistake. I didn't create a new model. What I have to do all the time, I have to create a new model. Then here choose boron and nitrogen 6x6, and then create a nanotube. Okay, now I want to enlarge it. Go here, display image from just below this left corner. You can choose editing, display, and image. I'm going here in the image. Now because nanotube is only periodic in one direction, so it will repeat only in one direction. I enlarge it like this one. See your structure. Then you can save it as your Siesta file. Let's say this is the boron nitride file. Now save it. Now you can see the bn.fk file is created for you. Anyone have any issue up to now? Anyone have any issue up to now? How many of you created a nanotube or silicon FDF file using material project? Anyone have any issue up to now? Okay, so I'm going to other software, that is the Molden. This is a post-processing tool. So maybe in next hands-on session, we will learn about this Molden and JMol as well. This is the Molden, what it can do for you. You can go this tutorial. The X Christian we will learn tomorrow maybe. Okay, for today, the GDS is enough. I think because the motto of this tutorial is to create a FDF file, that is the input file for Siesta. So for that, we need a software called the GDIS, and we learn how to create a FDF file in the GDS. We can create a carbon nanotube, we can create a 3D system, or we can search for our coordinate EIF file or XYZ file on internet, and just open it in GDIS and save it. Up to now, any issue, any? For more detail, as Verma sir posted in the group, you can follow his channel. You can do some basic calculation using his tutorial. You can go there. He posted the link with you in the group. So I'm moving to the third and the main tutorial of this hands-on, that is introduction to FDF file, or your input file for Siesta calculation. So when you open a terminal, let me close it, everything clean. Open a terminal. And if you type Siesta, Siesta, enter. Something is appear in front of you, that is welcome to Siesta. To run a Siesta calculation, you need three things. One is executable file, the Siesta executable file that we already installed it. If you have any problem with the Siesta installation, you can send the screenshot in the group. And another is the input file, that FDF file that we created using TDIS software. The third important file to run a Siesta calculation is pseudo potential file. For the pseudo potential, you can write directly here Siesta pseudo potential, or you can go to the Siesta website. You can find the pseudo potential there. You can download it and save it. Okay, in the FDF file, this FDF stands for flexible data format file. So flexible means you can write anywhere in this file, in any order. You can write integer, you can write a real number, logical numbers, like physical magnitudes. In any order you can write. In other software like that WASP, sometimes you need to follow the order, or sometimes you need to give the default value. But in Siesta, it will take a default value if you didn't define it. Sajal sir, you didn't create a new model. Is it CNT, or I'm not getting it? So the FD file you can write in any order. It is case insensitive. You can write in small letter. You can write in the capital letter. Like if you write lattice constant, it is equivalent to lattice constant, that is in small. To give the logical value, you can write true, you can write T, you can write yes, you can write no, and false, something like that. And physical magnitudes, you can give it in meter, centimeter, nanometer, angstrom, Bohr. And the thing is, you can include a file using just include command. Suppose you have two files. Suppose one is my CIF file, or let's say the coordinate file. One is my main file. I can include this file. I mean, when I run the calculation, I can give the name of this file, into this main file and run the calculation. So we can include the other file or other file from other directory as well. So in your input file, you have some general parameter, then some is your structural geometrical variables, some basis set, some variable controls, and how you are going to solve the Hamiltonian, and some parameter to control the self-consistent cycle. But for now, you can see in our FDF file, we have various parameters that we can include or exclude according to our need. So the first thing, I'm opening two files here similarly to compare it. Okay, the first thing is system name. I didn't put here. You can put SYS system name. Like here, I am writing silicon. Hexa. And the another is system label. System label I gave silicon. So what it will do for you when you run the calculation, your output file will be saved in the term of this, like here, silicon.dm, silicon.xb, silicon.band, silicon.dos, and then the next is number of atom. That is how many atoms in your simulation box. For silicon, here we have 8. It depends on your FDA file, how large is your supercell. Then next one is the number of species. Number of species means suppose you are working on gallium arsenide. You have two species, gallium and arsenide. For boron nitride, you have also two species, boron and nitride. But here we are doing only for silicon, so number of species we have only the silicon. The next one is the chemical species label. Suppose I have one chemical species, that is silicon, so I have to give the information of silicon in this particular box, like the serial number, then the atomic number, and the symbol of our silicon. Or suppose I have gallium arsenide, so I have to give the number 2, the atomic number of gallium, I don't know, XX, and then the gallium. I have arsenide as well, so arsenide and AS, something like this. So for now, I have only silicon, only one. Then you have lattice constant. This is your lattice constant. It is the length of your cell. Let me show you one this file, GDIS silicon.ftf file. You can see the length of ABC parameter of this box. It is defining by these lattice parameters. It is A, B, then the alpha, beta, gamma. These parameters can also define in the crystallographic way, like in not in crystallograph, but in the lattice vector parameter, like A2, B3, C1, C2, C3. Then you have these atomic coordinate format. These coordinate, it is either in B angstrom, it is either in B fractional or in Bohr. So here we have in the term of fractional. Then we have atomic coordinates. Here 8 atoms and their position A1, A2, A3, B1, ABC of second to second, third, fourth, and so on. So now what we will be do, we will come to this slide later, but first let me run a Siesta calculation to explain you a little bit more how you will be run the Siesta calculation. Just go to your day 1, then T1 folder, right click here. Here we have 2 files, silicon.fdf, that is the input file. I explained it a little bit up to here, and the pseudo potential file. And then we open a terminal here. So how you will be run this calculation, you have to do Siesta less than your FDF file name, that is silicon.fdf, then this symbol, or you can, instead of this, you can close this, and your output file name, let me write it output, or let me give any name, log.out, and hit the enter. It will start running. Because I have window, not this Linux 23, so sometime 22, so sometime it gives me error, so I need to do this. Silicon Siesta less than silicon.fdf file, then this symbol space TWE space my output file name, then enter. Try to do this, run this calculation. It is a short calculation, just within a few seconds it will be finished. How you will be run calculation, I'm showing you again. You have to go T1 folder. Inside that we have 2 files, silicon and this FDF file. You have to open the terminal. You have to open the terminal and give the command silicon less than this command, silicon less than your input file name T, then your output file name.
Yeah, Narendra, 1 minute. So in some system where that Siesta is installed, that the binary file, executive file, that may be in terms of sister.exe. So in spite of Siesta, you have to write sister.exe. Otherwise, that problem will not run. So use sister.exe and that FBF file, and then this T and output file. You can give whatever name you want. You can give your name dot out. So you will have that output file. So in this system where Narendra is running this program, that is in I think you are using in serial mode. Okay.
Yes, sir.
So that although this Siesta is installed in parallel mode, but Narendra is using in serial mode. Okay, good one. So I think for this exclusion of this Siesta, you need one input file. In this input file, all the information related to that particular species, particular material is there. If water is, you have to use that water molecule, then you need to give the information related to hydrogen as well as oxygen. Here that example is given for silicon. So one SI system is there, and this SI, that atomic numbers and all the chemical formula and chemical informations are given in this input file. And that the heart of this particular running this system is that PSF file. All the information means you can say that heartbeat. This is that body is FDF, and that heartbeat, that is that pseudo potential file. So you need that pseudo potential file related to each and every species. Here only silica is there, so you need one PSF file. And if you are using that water molecule, then you need two that pseudo potential file, one for hydrogen and second one for oxygen. So this is important thing, and you can go through that my that YouTube channel to detail of this, how that pseudo potential file can be generated, and this pseudo potential file can be obtained from a particular website. And this pseudo potential file generation method, it is described well by Mr. Narendra in his YouTube channel, and also in my one of this workshop in our laboratory. That pseudo potential file generation method had been discussed, and it is uploaded in that channel. So okay, don't go to that generation, that pseudo potential file. You can download from that internet. And one point you should note: you have to make Google as a good friend. So properly Google everywhere. If there is some error, just Google it. Just copy paste Google, because you are not the single one which who is facing the problem. There are so many sister users or material modeling tools users are there in the world, and they are facing the same problem. They are using Ubuntu. Same Ubuntu version they are using. Same sister version they are using. So the problem will be there. So anywhere they have posted that problem, and some solution might be given by some expert. So you can post that errors on Google, and you can get the answer also. So make Google as a good friend. This is a good tutor. So I think okay, proceed. We have to conclude. How much time we have? 5 more minutes. So you can conclude, summarize the session, Mr. Naren.
Yes, sir. I will. Can I take, sir, 10 minutes? Just I want to show the basis set difference. That is constant with the different basis set.
Yes, you can.
Okay, thank you. So when you run the Siesta calculation, you will be see end of run, then the job completed. If you go to that directory where you run your FDF file or Siesta calculation, you can see the different file with the different things. Around how many files you can see here. You have one output file, that is log.out. I give the name. When I run the calculation, I give Siesta silicon.ftf file, then the log.out. This is my output file name. So this file should be there here. If I open it, you can see it is a long file where this is some information related to Siesta version. I'm running in parallel or serial, running in serial mode. Then your FDF files, long file which contain your information of relax coordinates, your K point, stress tensor, force, and your self-consistent cycles. It is long file. If you go down, you can see in the end it is saying the job is completed. Now search for, if you hit Control F, search for relax to find the relax coordinate, because it did some optimization. The atom will change their position. So search for relax coordinate, RELAXED, relax. You can see here you have relaxed atomic coordinate in fractional. So what you have to do now, you have to copy this coordinate from here, copy and paste it in your FDF file. See here you have this is my output file. Here you can see I have relaxed atomic coordinate. I'm going to copy it and going to paste it in my FDF file. Okay, delete these, the previous coordinate, and I'm going to paste it a new coordinate, that is the relaxed one. The another thing is your cell vector. You can see the cell vector is 5.53. Before that it was 5.60. It is the important thing when we do the optimization, lattice parameter and the lattice coordinates. Before that, the initial coordinate was 6.00, 6.00, 6.00. But when I did the optimization, then I got the relaxed coordinate is 5.533. What I will be do, I will be copy this coordinate and paste it here. Really for the second one. Now this is, let me close my output file. Now this is my new FDF file with relaxed lattice parameters and lattice coordinate. Because the lattice parameter and lattice constant are multiplying with each other, so that means our lattice constant is 5.53. If you search on internet, the lattice constant, LATTE, lattice constant of silicon, you can see the lattice constant of silicon is 5.43, exactly the same. The lattice constant is 5.43 experimentally, but we are getting 5.53. As in the morning session, Professor Rodrigo sir said, you need to play with functional and the basis set, which plays an important role to get the exact lattice constant as the experimentalist. So in this FDF file, I used a basis set that is single zeta polarization, and the functional is LDA. I said if I go to that previous slide, we have 3 functional we can use, but for beginner we will try only LDA or GGA. And with this functional, we have a basis set, that is single zeta polarization, double zeta polarization. So if you go to the end of this tutorial, you can see this is the a case study of aluminium, where I tried to calculate the lattice constant and cohesive energy. We will do it tomorrow, cohesive energy. But for now, see the lattice constant, when I change this basis set PAO basis size with a single zeta, I am getting the lattice constant is 4.16, but the experimental lattice constant is 3.92. So what I did, I am just playing with the basis set to get the exact or the nearby the experimental value. So I changed the lattice constant with single zeta polarization, double zeta polarization, and I also tried this functional LDA or GGA. You can see the best one is the LDA, which is more close to the experimental value. So now you have the exercise here. What you have to do, you have to go to this exercise. Here you have two directories, basis size and the functional. Here just copy your relaxed file. That is, relaxed means you make sure you make sure you copied the relaxed coordinates and the lattice constant from your output file, and copy this file to your exercise directory. Go to the basis size and paste it here. I'm going to replace. So now play with these parameter basis size. Try it single zeta, same like this tutorial. Try this with single zeta polarization. This basis you have to play. Single zeta polarization, then double zeta polarization. Try this. Then go to the folder number 2. That is the functional. Change your functional from LDA to GGA and change your lattice basis size and play with this lattice constant and try to calculate which basis size and which basis functional is more closer to the experimental value, that is 5.43. So in this today's hands-on session, what we did, we installed some software to create a FDA file, some pre and post processing. Some of the software we will do next hands-on session. Then we create a FDA file and run the Siesta calculation. Then you have exercise, play with the basis size and basis functional and try to get the lattice constant around 5.43. And create a table like in that tutorial. The same you have to create for silicon. Forget this cohesive energy for the moment. Any question anyone have?
I think this is the end of today's session, and probably you enjoy it. It is some lack of computers here, so otherwise, this is a very, very wonderful hands-on session as far as my experience is concerned. And before we have done such sessions in different institutions, but simple and just calmly, simply just simple commands are there and running without error. Either you are not reporting the errors or there is no error. So this is a good session. So thank you, Narendra. And I think take some rest. So we will meet tomorrow. Thank you all. Oh, ma'am, please, कुछ कहना है तो?
I would like to thank Professor Mohan Verma sir and Narendra Kumar sir for this helpful hand-on session. And now today we are going to end this session. Thank you. Thank you.
Thank you very much.
And the tomorrow's program will be start at 11 a.m. sharp. And all the participants are requested to join